Okay, class, we're on to 6.4. Solve compound inequalities. So compound means when you have things together. So we're going to see a compound inequality consists of two separate inequalities joined by an and or. Okay, so it's either an and. I know it sounds weird to say or and or. Okay. So the graph of a compound inequality with and is the intersection of the graphs of the inequalities. So the intersection, so the way I like to say it is, so say you have x is greater than -2 and x is less than or equal to 1. So you can see that this is graphed like this. We've been looking at that earlier. So it doesn't include -2 and it's going up the number line, and then x is less than or equal to 1. So you can see it's closed and it's going this way. So an and puts them together, and I always think of it between. It's normally between two numbers. So -2 is the smaller number and 1 is the larger number. So you always go left to right. You would never say 1 to -2. You always do the way the number line does. So it goes from -2. That's how you put them together and they become a compound. And I think, like I said, the best way to think is and is between two numbers. So from -2 to 1, you join these two together and you get between two numbers. And then the other way is an or. So look at this. The graph of a compound inequality with or is the union, okay, so of the graphs of the inequalities. So say I have x is greater than or equal to 0. So 0 again is closed because it contains an equal sign. Sorry, let me move that out of the way. And it goes up the number line. Then -1 is greater than x. Again, we should remember that this is going to be an open circle because it doesn't include. So it goes from -1 all the way down the number line. So the way that you think of an or is, look, I always think of them as separate. So one part of it goes from -1 down the number line. The other starts at 0, includes 0, and goes up the number line. There are exceptions to these rules, but for the most part, and that normally gets when you get up higher in math. But for the most part, your and are between numbers, your or separate. They go one side and the other side of the number line. Okay, so let's go ahead and start to solve some of these. So we're going to translate a verbal phrase into an inequality. So I'll write the verbal phrase, all real numbers. That's my shortcut for all real numbers. Sorry here, I'm kind of lazy sometimes, so I want to write it real quick. All real numbers that are greater than -2 and less than 3. Okay? So remember, this is a compound inequality, and one of the tip-offs is if it uses the word and or. So here is the word and. So as soon as I see and, I know it's between. So you might want to put that down in your notes because those things help tremendously. So all real numbers that are greater than -2 and less than 3. So do a number line. You definitely want to have -2, so let's just say -3. Okay, -1, 0, 1, 2, 3. Definitely want those. If you want to extend it to 4, sorry, it doesn't look the greatest, but you get the idea. So x are the numbers between, okay? So let's read the part first. All numbers that are greater than -2. Okay, so that means these numbers are going this way. But then they've got to stop because x is less than 3. So we can only go up to 3 and no more, and it doesn't include, because it doesn't say or equal. So the x's are less than 3, and then they're greater than -2. So that gives us a and it's a between these numbers, not including -2 and not including +3. Okay, so let's go ahead. So there's an example of an and. Let's look at one of an or, where they go one side of the number line and the other one. So let's go ahead and let me find one. Okay, so again, all real numbers. That's my shortcut for all real numbers that are less than 0 or greater than or equal to 2. Okay, so the or here, less than 0 or greater than or equal to 2. So you see that the or is being used, so that's your tip off that you are looking at two separate inequalities. So the numbers they're mentioning are 0 and 2. Okay, so do your number line, and we can say 0 and do -1, 1 and 2. Actually could have spaced them out further. Let's do 3 so it looks a little bit more balanced. Okay, so all the real numbers, so that's the first part of the compound inequalities. So all the real numbers are less than 0. So it does not include 0. All the numbers that are less than 0 would look like that. That's that part of it. So think of them as two separate inequalities, and if you do that and read them and understand what you're reading and you practice these, then it will get easy to go ahead and graph them. So that's the first part, or greater than or equal to. So the or is where we can tell that it is a separate compound inequality. This or means or equal to with the equal sign. So greater than or equal to 2. So this is where this equal to here means that it's a closed circle, and it's greater than or equal to 2. So it's heading up the number line. So the or, one side of the inequality or the other side. Alright, so that's the difference between the and or the ors. So let's go ahead and solve some of these. So let's start with something that's not too bad. So that was a word problem, but a lot of times, most of the time, you just see them as an inequality. And it's easy to recognize if it's going to be an and or an or. So here we go. It says solve 2 is greater than x plus 5 is less than 9. Okay, so remember we had done the and the and I told you was between two numbers. So it's very easy to spot algebraically. So you've got these numbers and you've got this statement between these. So this is definitely an and. So we have to solve it like we would an equation, but you have to think about having like equations on both sides. So I've got a plus 5 and I need to bring it here, and I need to bring it to both sides, the left and right. So I'm going to subtract 5, but then I'm going to subtract 5 on the right side, and I'm going to subtract 5 on the left side. So this is gone, and x is greater than 2 minus 5, which is -3, less than 9 minus 5, which is 4. So you can see that when we end up, this is definitely an and, because it's sandwiched between two numbers. And we make sure that it goes from left to right, so -3 up to 4. So that does make sense. So real quick on a number line, you can put -3. You can fill out all the numbers here if you want, or just kind of put -3 and 4, and you can put a number in the middle. I kind of do that because it accomplishes the same thing. Okay, so none of these numbers are included, so open circle and open circle. So it's saying x is greater than -3, so x is around here. But then 4 is greater than x, meaning that we can't go past that boundary. So that's an and. Always think and sandwiches it between numbers. Alright, let's try another one. I'm going to do one with a bunch of negatives. Okay, so -7 is greater than -x minus 1 is less than 3. So here we go. So we've got the z that we want to end up with a positive z at the end. So the first thing that you want to do is get rid of the -1, so you're going to add 1. And remember, whatever you do right here in the middle, you have to do to both sides of the inequality. So I've got to add 1 to the right side and add 1 to the left. -7 plus 1 is -6 is less than -z. Make sure you always bring down the sign, is less than 3 plus 1 is 4. Okay, so you can clearly see that that z, the variable, is sandwiched between numbers. So again, this is an and. But here now, remember the same rules apply, they never change. You have to divide the -1 away. So I have to divide it by both. So as soon as I divide by negative, this flips. So -6 divided by -1 is a +6. Z is now positive because negative divided by negative makes it positive. So again, I've divided this side, so I have to flip the inequality. 4 divided by -1 is -4. Okay, so it's really important if you forget to flip when you're dividing or multiplying. So the rules that you learned at the beginning apply always with every inequality. Whenever you're dividing or multiplying by a negative, you have to flip that inequality. But remember, we read on the number line from left to right. So we would never go from +6 to -4. So we need to switch it around, not change anything, but put -4 here and 6 here, and put z in the middle, and then read what it says. This is facing towards, so z is greater than -4. So we're keeping it the same way, see? And then 6 is larger than z, so this would do this. So we haven't changed this inequality, we've just rewritten it so that we can graph it without any problems, because if you try to graph from 6 to -4, it's completely wrong. Remember, you always go from the lower numbers to the higher, always. So you just rearrange it because you're reading it. Like, I can see it because I've been doing math, I know what it says. But if you're just starting out and you don't go ahead and write it in a way that you understand it, you're going to graph it all weird. Okay, so let's go ahead and do a number line, -4. Let's put maybe a 0 in the middle and a 6. So now we say z is greater than -4. It doesn't include it. So it's going between -4 and 6, basically. It's an and. Okay, so you can see an and is between numbers. So if you connect those two things together, you won't have a hard time solving these things. So let's move on to some another and then we will get to an or. So we have -5 is greater than, is greater than or equal to -x minus 3, is greater than or equal to -5, is less than or equal to 2. Okay, so 2 is greater than or equal to this statement here, -x minus 3, and this is greater than or equal to -5. Okay, so you can see that again it's an and. it looks like it. You have to solve it to be absolutely sure. There are odd ones that look like and when they're finished, the inequalities flip and they become ors. So for the most part, the way it looks is the way it's going to be at the end, but there are always those rare cases or different ones that turn out a little bit differently. But let's go ahead and solve it. So we're going to add 3 and add 3 to both sides, the left and right. So -5 plus 3 is -2 is less than or equal to, and you have to bring down the sign so it's -x is less than or equal to 2 plus 3 is 5. Okay, so I can clearly see that this will be an and. So divide by -1. So again, as soon as we divide by a negative, this becomes a +2. We have to flip this inequality, and that becomes +x. We flip this one. You have to flip both of them. 5 divided by -1 is -5. So it looks like one that we just did. So we're never going to look at the number line and say it's between 2 and -5. It has to go from -5 to 2. So let's go ahead and rearrange it. That's all you're doing. You're not changing what it's saying. X is obviously in the middle. Read it. 2 is greater than or equal to x. So the way that it is facing towards 2, it's the same way here. Then x is greater than or equal to -5. So I'm just rewriting it, but I'm not changing anything. Now it makes sense. X is greater than or equal to -5, and x is less than or equal to 2. So, and it goes from negative to positive. So -5, go ahead, place our 0 and 2. But now you can see the difference. Both numbers are included. Okay, so we want to put a closed circle here and a closed circle here, and all the numbers in between here are included. That's what this inequality is saying. So if I looked at that inequality and I said, is 0 part of the solution? You would say yes. If I said, is -5 part of the solution? You should say yes. If I asked you if -10 is, no, it's outside. It's not part of the solution, nor is 3 or 4. So that's what it means, that these x values, these numbers in between, are all part of the solution. Okay? So now we're finally going to get to an or. So we've seen a ton of ands here. All right, so here's an or, and it's very self-explanatory as we write it, and you'll see it looks completely different because they're separated. 2x plus 3 is less than 9, or, so it will write the or in between. 3x minus 6 is greater than 12. Okay, so all you do is solve one and then solve the other, and we're going to graph them. So -3, subtract 3 from both sides. So 2x is less than 9 minus 3, which is 6. Divide by 2, and x is less than 3. Or, keep the or, so that's one part of the compound inequality. The other part is this one. We're going to add 6. Then we're going to add 6 here. So if math just works slow and steady, and it will get easier and easier. So 3x is greater than 12 plus 6 is 18. Divide by 3, and x is greater than 6. Okay, so again, do the number line. We can put -3 and 6. Okay, you always do the number line as you read it. So I'm going to pick a blue here. This part of the inequality says 3 is greater than x. Sorry, I put -3. I meant to put a +3. Alright, so 3 is greater than x, so go ahead and put an open circle, and it's pointing that way. Then the other part, or x is greater than 6, again does not include 6, and it goes up like that. So you can see that they're clearly very different. Okay, let's do one more OR. Let me find a good one. Okay, so here's one. 4c plus 1. Make sure that you can see it clearly. There it is. 4c plus 1 is less than or equal to -3, or 5c minus 3 is greater than 17. Okay, so you can clearly see the difference between an AND or an OR. So they're both compound inequalities, meaning there's two of them, but the AND are one side to the other from this number to that number, and they join together. Then the OR is going normally down the number line, and the other one's going up the number line. There are exceptions, but for the most part that's how it's solved. -1, subtract 1. 4c is less than or equal to -3 plus -1 is -4. Divide by a +4, so we don't have to worry about flipping anything because we are dividing by a positive. -4 divided by +4 is -1. So then we have the OR, the other part of the compound, so add 3. 5c is greater than 20. Divide by 5, and c is greater than 4. Alright, so now we've solved that. Let's do a quick number line. Put -1 here and 4 here. That's all you have to do. You don't have to fill out a bunch of numbers, just what you need. So you know this part is -1 is greater than or equal to c. So it includes this, and it's headed down the number line just like it shows you. This arrowhead is headed up the number line, so it does not include 4. Open circle and then graph it towards the higher numbers. Okay, so that's given you different ones and different practice with the compound inequalities, and we will be moving on to 6.5. So hopefully you're understanding this. Videos are helping you. So God bless you guys, and we will do 6.5 tomorrow, okay?